Hello there, and welcome to Science for Sleep, where curiosity drifts gently and science hums quietly beneath the stars, where the big questions don't demand answers, just room to stretch out and settle in. Tonight's quiet wandering takes us somewhere unexpected, into something impossibly small, yet utterly vast, something we often fear, occasionally fight, and rarely understand. Viruses. Not exactly the first thing you think of when you picture something peaceful, but stay with me. These tiny, spiky bundles of code, invisible, unliving, unstoppable, have shaped our world more profoundly than most mountains or monarchs. They've rewritten the story of life itself, and in many ways, they rule it. Where are you listening from tonight? Is it quiet where you are? Has the day been long, or is it just beginning? Funny, isn't it? That across all these cities and time zones and sleepy corners of the world, we're connected not just by light or language, but by the quiet breath of biology, some of it written by viruses. If you find this little voyage soothing, or simply a gentle companion to a fading day, I'd be so grateful if you'd like the video, or subscribe. It helps this soft corner of calm reach others drifting through their own restless evenings. So go ahead, lie back, let your thoughts settle like dust in still air, because somewhere between fever dreams and genetic whispers lies the strange, elegant kingdom of viruses. Let's begin. It's strange, isn't it, how something so invisible can take up so much space in our minds. Viruses aren't something we see or hold or hear. They don't glow in the dark or tap us on the shoulder, and yet they live in the background hum of worry, in headlines, in memories of masked mornings and empty streets. For some, they bring back a deep recent stillness, that hush the world fell into when the air itself felt uncertain. For others, it's more personal, a childhood fever, a forgotten vaccine, a sense that we're always somehow on the edge of something microscopic and beyond our control. Even the word virus carries a quiet unease. It slips into conversation like a whisper. Flu season, outbreak, pandemic, infection, unwelcome visitors, all of them. But here's the twist, and it's a curious one. These microscopic creatures, if we can call them that, don't just make us sick. They shape us, change us. Sometimes they build us. The average person carries more viral DNA inside their cells than actual human genes. That's not a metaphor. That's your body, your bones, your breath, your memories, riding on an ancient river of viral history. Millions of years ago, viruses infected our ancestors, and then stayed, not just in bloodstreams or lungs, but in the code, quietly written into the very script of who we are. And when we look at life, really look, not from the level of hands and hearts, but from the swirling scale of cells and time, a pattern emerges, one that feels oddly poetic, that even our enemies help create us. It's unsettling, isn't it? To think that something so often framed as evil might also be essential, that without viruses there might be no mammals, no placenta, no birth, no us. You've probably had a virus before, a cold that crept in just before an important day, a fever that burned through a weekend and left you oddly changed. It's easy to remember the discomfort, the tissues, the tea, the dull ache of waiting, but harder to notice what your body was actually doing. Fighting, yes, but also learning, storing information, building a library of encounters that would one day protect you, quietly, without thanks, from future invaders. That process, it's called immunity, but it's also a form of memory, a biological diary of everything you've ever faced and survived. Every cough and sniffle, a page turned, every antibody, a bookmark, and somewhere deep inside you, your marrow, your blood, your cells, that story continues to write itself. So when we talk about viruses, we're not just talking about sickness, we're talking about relationship. The push and pull between host and hitchhiker, us and them, the ancient handshake that keeps reshaping life. And maybe, just maybe, that's what makes them so fascinating. Not just because they're dangerous, although some certainly are, but because they sit right at the edge of what we consider living. They can't move on their own. can't reproduce. They don't eat or breathe or grow. They drift, they wait, they attach. And only inside another living thing do they truly come alive, like shadows needing light to make sense. This in-betweenness, not quite alive but not dead either, gives viruses an eerie kind of poetry. They are passengers, and sometimes pirates, harmless stowaways, and sometimes saboteurs, but always a part of the world we live in. And so, here we are, fragile, complex creatures wandering through a planet thick with unseen things. Each breath we take holds thousands of microscopic particles, most of them harmless, some of them essential, a few of them waiting for the right key to turn. We don't often think about it. How every crowded train, every handshake, every sneeze carries with it a possibility. A particle passed, a message delivered, a chain of events we'll never see, but might one day feel. And perhaps that's the strangest thing, that the very fear we feel around viruses is also a reflection of awe. Because to change something as complex as a human being, to rewrite its code with nothing but a strand of protein and time, that is a kind of power. One we don't fully understand, one we can't easily tame, and one we quietly respect. Of course, viruses don't know they're powerful. They don't plan or plot or take pleasure in their impact. They're not alive in any traditional sense, but their presence, their persistence, their sheer ability to endure, from the frozen Antarctic to the deep ocean vents, from ancient bat caves to the bloodstream of presidents, that's something remarkable. And it's not just human bodies they inhabit, it's every corner of life. Trees, whales, coral reefs, birdsong. Even the bacteria in your gut are at war and peace with their own viruses, called bacteriophages, silent regulators of the microbial world. If all life is a web, viruses are the breeze that shakes the threads. And when you think of them this way, not as intruders, but as ancient restless messengers, something begins to shift. The fear softens, the curiosity grows, and suddenly the question is no longer, how do we stop viruses, but what are they trying to tell us? Are they reminders that life is delicate, that change is inevitable, that we are never truly alone, even at the smallest scale? Or are they simply chaos, wrapped in protein, drifting through a world that was never ours alone? Whatever the answer, one thing is clear. We live in a world that's constantly rewritten by things we cannot see, and whether it's a sneeze or a species-wide transformation, that quiet influence is always there, a presence on the edge of perception, like wind, like time, like sleep itself. So the next time you cough, or feel a chill, or simply lie awake at 3 a.m. wondering what's moving unseen around you, remember this. You're not weak. You're not broken. You're part of something ancient. A dance between systems, a biological dialogue that stretches back billions of years. And even as we build vaccines, study genomes, craft medicines with names longer than lullabies, the mystery remains. Why do viruses exist? Why are they so successful? And what does it say that a fragment of non-life can hold so much sway over everything that breathes? The answer is coming, but not yet. Let the questions linger a little longer. Let your mind settle with the quiet wonder of it all. We'll explore the history, the science, the strange victories and eerie elegance of viruses soon. But for now, let's stay here, in this space between fear and fascination. This strange calm at the edge of knowing. You're not alone. Not in your thoughts, not in your breath, not even in your DNA. You're built from billions of years of encounter. And tonight, as the world slows and the sky softens, that story continues as quietly, invisibly, like a virus carried by the wind. Long before we had microscopes, before vaccines, before the word virus ever slipped into our vocabulary, we were already haunted by them. Or rather by something invisible. Something that came in waves without warning, that stole breath and voice and whole generations, and then vanished again, like a ghost slipping back into the woods. In the ancient world, illness was mystery incarnate, a punishment from the gods, a spirit unsettled, a curse perhaps, a test. There were no petri dishes, no germ theory, no Latin labels for strands of protein, but there was pattern. A child healthy in the morning, fevered by night, a village coughing in chorus, the black flecks of blood, the soft rattling in the chest, the sudden quiet that followed. And so we named the unknowable. We wrapped the unseen in stories. The Babylonians believed in demons called utuku, spirits that slipped into bodies and minds. In ancient Egypt, illness was the domain of Sekhmet, the lion-headed goddess of war and plague, feared and revered in equal measure. In Greece, Hippocrates tried to ground these visitations in nature, to study fevers and flux as matters of balance, not vengeance. But even then, the line between medicine and myth was a thin one. People didn't just treat illness, they mourned it, feared it, built rituals around it. In medieval Europe, outbreaks were often seen as divine wrath. Penance swept the streets. People walked barefoot through towns, whipping their own backs in hopes of cleansing the world of its sins. And when the plague came again and again, it felt like the breath of God, or the devil, brushing too close. No one could see it, but they could feel it. And when you feel something invisible move through a family, a village, an empire, you give it power. Not scientific, perhaps, but cultural, spiritual, emotional. And so, slowly a language began to grow. In ancient Sanskrit, the word rogi, the sick one, was balanced by vidya, the healer. In Chinese medicine, illnesses were linked to wind, cold, dampness, not just poetic, but observant. They noticed the seasonality, the subtle triggers, the way one person's breath could shift another's fate. And in some indigenous cultures, illness was a story, not just of the body but of the spirit, a message, a warning, a misalignment between self and world. There's something beautiful in that, and heartbreaking too, because even without germ theory, people still knew they were fragile, still understood that health was a kind of harmony, a balance that could be undone by something unseen and relentless. And when that balance broke, when cough turned to fever and fever to silence, they lit candles, they prayed, they told stories. Because what else could they do, really? In the Americas, long before colonization, many cultures had herbalists, midwives, shamanic healers who understood infection in their own way, not as a battle, but as an energy shift. They brewed teas from bark, used smoke as cleansing, and treated the sick with song as much as with poultice. Then came the ships, and with them came smallpox, measles, influenza, diseases carried by strangers, not just in blood, but in breath. To those who had never known such things, it was devastation. Whole cultures shattered in the span of weeks, not by sword or fire, but by something that couldn't be seen. A virus, unnamed, uncared for, unstoppable. And even centuries later, that echo lingers. The idea that something so small could carry so much power. In Japanese folklore, there's the concept of yakubugami, spirits of illness that wander the world, settling where energy is low or defenses are weak. They aren't evil exactly, just persistent, like wind through an open window. In the English-speaking world, we called them plagues, pestilence, the pox, a single syllable packed with fear. Even the word influenza comes from the Italian influenza, meaning influence, because it was once believed that sickness came from the stars, that certain alignments in the heavens rained down waves of illness. And perhaps in some poetic way, that's still true, because viruses don't just move through lungs and cells, they move through culture, through memory, through story. Think of how illness changes language. Patient zero, going viral, outbreak, containment. These aren't just scientific terms. They're cultural furniture now. Words we sit on without thinking, shaped by centuries of collective experience. Think of nursery rhymes, ring-a-ring-a roses. A sweet little song that may trace its roots to the Black Death, when flowers were used to mask the scent of sickness. Or fairy tales, the sleeping sickness, the poisoned apple, The idea of a single touch, a kiss, a curse, a prick of the finger, changing everything. We've always understood that transformation doesn't need to be loud, that the most powerful forces are often the quietest ones. And that's the paradox of viruses. They are terrifying not because they are big, but because they are small, because they remind us that being alive is a vulnerable act, that breath itself is a risk, and yet we take it again and again. In the early 20th century, the Spanish flu swept through a world just beginning to recover from war. It killed millions, changed medicine, changed cities, and yet for decades afterward, it was barely spoken of, tucked away in memory's attic, too big, too raw, too invisible to fully hold. And then, a century later, it happened again. You remember how quiet the streets became, how uncertain the air felt, how the word virus slipped into daily conversation like it had always been there. It wasn't just biology, it was history repeating itself, in masks, in fear, in nightly briefings and tired doctors and empty shelves of paracetamol. But also in resilience, in candlelight vigils and balcony songs and letters passed through windows. Because when viruses strike, they don't just test our immune systems, they test our stories. They ask us what we believe about cause and cure, about safety and connection, and we answer, sometimes with science, sometimes with myth, sometimes just with kindness. Even now, you'll hear echoes of the old ways, people blaming the sick, calling it punishment, or karma, or fate, and others lighting candles, writing poems, singing lullabies for the ones who didn't make it through. There's no single way to respond to something unseen, but there are patterns, and those patterns stretch across time, across culture, across the shifting boundaries of language and land. Because viruses aren't new, they're older than us, and in some ways, wiser. They've watched empires rise and fall. They've travelled in the blood of kings and the breath of beggars. They've ridden on the wings of birds, the backs of bats, the bellies of whales. They are everywhere, and always have been, and still, we endure. Not just because of medicine, but because of meaning. Because we keep making sense of suffering, through myth, through metaphor, through science that grows more poetic with every discovery. What once was a curse is now a code. What once was an omen is now a sequence of proteins. And yet the all remains. Because even with all we know, the vaccines, the microscopes, the genome maps printed in labs like holy texts, there's still a whisper of mystery, still the soft breath of something older than language, older than fear, older than us. And that's the heart of it, really. Viruses are not just invaders, they're storytellers, shaping not just our bodies but our beliefs, telling us, in ways both brutal and beautiful, that life is not static, that it moves, that it shifts, that it carries within it the capacity for sudden, quiet change. So the next time you hear the word virus, don't just think of illness. Think of myth, of music, of mothers watching over fevered children, of scrolls and herbs and stars aligned, of the many ways humans have tried to understand the invisible, and the many ways we still do. Because viruses don't just infect, they reflect us, our fears, our strength, our stories. And somewhere, in that ancient echo, from Babylonian demons to digital genomes, we might find something quietly miraculous, a continuity, a thread, a reason to keep breathing, even when the air feels uncertain, even when the story isn't finished yet. If you could shrink yourself down, smaller than a cell, smaller than a bacterium, smaller than breath, you'd find yourself drifting in a microscopic sea, and in that sea, barely more than a wisp of geometry is a virus, not alive, not quite dead, not crawling or floating or breathing, but waiting. This is where things get strange. Because when we talk about viruses, we're not talking about life as we know it. They don't grow, they don't metabolize, they don't eat, excrete, or fall in love. They're not creatures exactly. They're more like blueprints wrapped in boxes, instructions, not for themselves, but for us. And yet, for something so simple, They've conquered nearly every corner of Earth. So what are they really? At their core, viruses are made of just 2 or 3 parts. A genetic code, either DNA or RNA, a protective shell made of proteins, and sometimes, if they're feeling fancy, a greasy outer layer called an envelope. That's it. No organs, no limbs, no nucleus or cytoplasm or buzzing inner workings, just a message and a key. But here's the unsettling bit. That message, it's meant to trick your cells, to convince them, politely at first, then very persuasively, to stop what they're doing and start building more viruses instead. Imagine handing someone a recipe and watching them make hundreds of copies, not realizing the recipe slowly erases everything else they knew how to cook. That's what a virus does. It hijacks, not with malice. It has no emotions, not with strategy. It has no thoughts. But with astonishing precision, it lands, it binds, it enters, and once inside, it whispers to your cell's machinery, "Forget everything, make me." The cell obliges. It reads the viral code, assembles the pieces, and produces an army, until eventually the cell bursts, or withers, or becomes a permanent little factory of infection. And then the copies scatter, and they do it again. It's like origami folded by the wind, unthinking, unstoppable, beautiful in its own bleak way. But not all viruses are equal. There are thousands, likely millions, of different kinds. Some infect humans, some infect plants, some specialize in bacteria, swooping in like tiny microbial hawks. Others haunt deep-sea creatures we've never seen, or quietly float through forests without touching a single leaf. They're old too. Very old. Far older than mammals, older than fish, older than plants that bear fruit. Some scientists believe viruses may predate cellular life altogether, that they were part of the primordial soup, those strange early molecules that twisted themselves into patterns long before there were eyes to see them. In that sense, viruses aren't just passengers of life. They might be its co-authors. We often imagine them as outsiders, invaders that sneak in from the shadows. But that's not the full story. Many viruses have lived alongside us for so long, they've become part of us, and not just metaphorically. When you zoom in on the human genome, those 3 billion letters that make you, you'll find that a shocking portion isn't really human at all. More than 8% of our DNA is made from the remnants of ancient viruses. They're called endogenous retroviruses, ghosts of past infections that slipped into the germline, into sperm and egg cells and decided to stay. Generation after generation, they've been copied forward, sometimes mutating, sometimes falling asleep, sometimes waking up. They're like fossils in digital form, but instead of stone, they're made of code. And here's where it gets really wild. Some of those viral stowaways turned out to be helpful. One ancient viral gene, for example, helped early mammals develop the placenta, a structure that allows nutrients and oxygen to pass from mother to child. Without that borrowed viral blueprint, it's possible mammals, including us, wouldn't have evolved the way we did. Think about that. Something that once invaded a cell became the bridge between generations. That's not just biology, that's poetry. And yet, for all their elegance, viruses remain deeply unpredictable. Some are so harmless you carry them for life and never know. Others lie dormant, then awaken with age or stress. A few are fierce, quick to spread, quick to harm, and fewer still, like HIV or rabies, are devastating in their persistence. But in every case, they rely on the same strange trick. They don't live on their own. They use us. Every cough, every surface, every shared sip of tea is a highway for something that can't move without a ride. They're the ultimate hitchhikers. And Earth? Earth is full of roads. In fact, if you gathered all the viruses on the planet, not just human ones, but marine, microbial, animal, fungal, and stacked them end to end, they'd stretch past the edges of the galaxy. Not metaphorically, literally. There are an estimated 1031 virus particles on Earth. That's a number so big, it outnumbers every star in the universe. 1 million viruses for every grain of sand. Most of them will never touch us, They infect algae or fungi or things we haven't named yet, but they are there, a constant swirling presence, invisible but not idle, and in many ways they help regulate the world. In the oceans, viruses burst open bacteria and phytoplankton, releasing nutrients back into the water, fueling the great cycles of carbon and nitrogen that support all marine life. Without viral activity, many ecosystems would simply collapse. They're not just agents of death. They're part of life's great recycling system, a kind of microbial housekeeping, invisible caretakers, silent editors, but still, they remind us that nature doesn't owe us clarity or kindness, that the world we live in is porous, shared, and full of things we cannot see, but that see us. And that brings us to one more uncomfortable truth. Viruses evolve faster than almost anything else on Earth. Because they reproduce so quickly, and often sloppily, their genetic code is constantly mutating. Sometimes those mutations break them. Sometimes they do nothing. But every now and then, a mutation makes a virus better at what it does. Better at spreading, better at hiding, better at surviving. And that's when we notice. That's when the coughs start, the fevers, the chain reactions across airports, classrooms, city streets. And it's in those moments that we remember we are not alone in this world, not even in our breath. Let's drift back to the beginning, not of humanity, but of the planet itself. Roughly 4 billion years ago, the Earth was young, hot, restless. Volcanoes roared, oceans simmered. The air was thick with elements trying to decide what they wanted to become. And somewhere in that chemical chaos, tiny structures began to form, self-replicating molecules, simple, stubborn strands of information. Some of those became cells, others became something else. Some scientists believe viruses may have emerged right alongside life itself, not as late arrivals, but as parallel possibilities. Not quite life, but not nothing. Just instructions, learning how to echo. There are theories, of course. 3 main ones, to be precise. Like all good mysteries, no one can quite agree on the origin story of viruses. The first is called the progressive hypothesis, the idea that viruses began as rogue genetic elements, little fragments of DNA or RNA that broke away from living cells and decided to go solo, like paragraphs escaping a novel and trying to become a book of their own. Then there's the regressive theory, that viruses were once full-fledged cells, but over time lost all the machinery they didn't need, simplified themselves into something leaner, meaner, more efficient, not builders anymore, just replicators. And finally, the virus-first model, a daring proposal that says viruses came before even the first cells, that they're not remnants or rebels, but the ancestors, the original whisperers of code. No one knows which is right. Maybe all of them are, in different ways. Maybe viruses don't come from a single origin at all. Maybe they've simply always been there, like shadows waiting for something solid to cling to. What we do know is this: they are masters of adaptation. Let's take a closer look at how they do what they do. The viral life cycle, if you can call it that. It doesn't have the stages of birth, growth, reproduction, and death. Instead, it has moments, a kind of choreography. First, attachment. The virus finds a cell, the right kind of cell, one with a door it knows how to unlock. This part is remarkably specific. Some viruses only infect certain species, others only certain tissues. The common cold virus likes your respiratory tract. HIV targets your immune system. Rabies finds its way to nerves. It's not personal, it's molecular lockpicking, a match between viral proteins and cellular receptors. A key turning in a lock it was built to fit. Then, entry. The virus slips inside. Sometimes it fuses with the membrane. Sometimes it's swallowed whole by the cell and breaks out of its little endosomal prison. Once inside, it uncoats, shedding its protein shell to release the precious cargo within, its genetic material, the blueprint, the plan. Then comes replication. And this is where the real takeover begins. The cell, poor thing, doesn't realize what's happened. It simply sees code and does what it's always done. Follows instructions. It starts making viral proteins, copying viral RNA or DNA, building pieces, folding them, assembling them. Like a haunted factory producing parts it doesn't recognize. And when the pieces are ready, the virus assembles itself. One by one, the components lock together, forming brand new particles, dozens, hundreds, sometimes thousands, and then release. The cell may burst open, or gently push the new viruses out one by one, and those fresh copies scatter into the body looking for new hosts, new keys, new doors. It's quick, efficient, unforgiving, a life cycle without a life. And yet, among all this precision, viruses leave room for error. In fact, they depend on it. Because viruses mutate, often, especially RNA viruses. Their replication enzymes, the ones that copy their genome, are sloppy. They make mistakes, and those mistakes are sometimes upgrades. A single letter changed in a genetic code. A single protein folded differently, and suddenly, the virus is better at escaping the immune system, better at binding to cells, better at surviving. This is why we get new strains, why flu season doesn't look the same every year, why a virus you've had once might still get you again, because viruses are always rewriting themselves, not with purpose, not with malice, just because. Evolution without intention, change without a goal, adaptation as a side effect of chaos, and still, for every virus that causes disease, there are countless others we'll never notice. They drift in the air, float in oceans, lurk in soil. Some infect bacteria. In fact, the most abundant viruses on Earth are bacteriophages, viruses that specialize in attacking microbes. You could fit 100 million bacteriophages on the head of a pin, and they'd still be outnumbered by how many exist in a single teaspoon of seawater. They're so effective they actually control bacterial populations in nature, pruning ecosystems like unseen gardeners. In your gut, phages help maintain balance. In lakes and rivers, they help recycle nutrients. In science labs, they've become tools to edit genes, to track infections, even potentially to fight antibiotic-resistant bacteria. That's right, we may someday treat deadly bacterial infections with viruses. It's not science fiction. It's already being tested, because what was once seen only as threat might now be ally, and that's the quiet revolution happening in virology. We're beginning to see viruses not just as invaders, but as participants, shapers of evolution, bridges between species, pieces of the puzzle we didn't even know was incomplete. They've changed how species emerge, how genes move, how complexity grows. They've left fingerprints on the genome of almost every living thing, including you, and in some strange, subtle way, they might be guiding where we go next, not as puppeteers, but as passengers, quiet passengers with a strange influence on the map. Of course, some viruses remain devastating. Ebola, Zika, HIV, SARS-CoV-2. Their names alone carry weight, stories, statistics, empty chairs at kitchen tables, and those stories matter. Viruses may be natural, but suffering isn't neutral, so we learn, we prepare, we build vaccines, one of humanity's greatest achievements. We create antiviral drugs, we study viral evolution with tools unthinkable a century ago. But still, we stay humble. Because the world of viruses isn't just a battlefield, it's a mirror. It shows us how fragile we are, how adaptable, how connected. It reminds us that life doesn't have borders, that a bat's breath can ripple across continents, that what happens in one corner of the forest can one day arrive at your door. But it also shows how resilient we are, how a single vial of vaccine can save millions, how a community can flatten a curve, how science and compassion can work together, and perhaps most humbling of all, that even after centuries of study we still don't fully understand them. Not entirely, not completely. Because viruses operate on the edge of life, and on that edge, things get weird, things get beautiful, like language without a speaker, music without a musician, a message in a bottle drifting between cells, changing the story one whisper at a time. If viruses were just invaders, their story would be simpler. They'd enter, replicate, destroy, and that would be the end. But they don't just break things, they reveal things, they tinker, they blur boundaries, and the deeper you go, the stranger it all becomes. Let's begin with a curious twist. Some viruses don't destroy their host. They don't burst the cell open or leave it for dead. They stay, quietly, in a state scientists call latency. These viruses, like herpes simplex or varicella zoster, slip into the cell, insert their DNA into yours, and rest. No symptoms, no replication, just stillness, a kind of molecular hibernation. But they don't forget. Years later, with the right trigger, stress, illness, a flicker of immune distraction, they awaken, and they resume their dance. A cold sore after a hard week, shingles decades after childhood chickenpox. It's not reinfection, it's remembrance. These aren't new visitors, they've been with you all along. And then there are viruses that rewrite more than the moment. They rewrite generations. Retroviruses, like HIV, have a particularly elegant trick. They turn their RNA into DNA, then insert it into the host genome. Not just in a random cell, but in a permanent way, like carving their name into the wall of the library. If the infected cell is a germ cell, a sperm or an egg, the viral code becomes heritable. It becomes part of the lineage. And just like that, a virus becomes a genetic ancestor. Not all retroviruses cause disease. Some lie dormant forever or mutate into harmless fragments. But some, like HIV, remain persistent, difficult to treat, difficult to cure, their DNA hidden in ours. This is part of what makes them so difficult to eliminate. You're not just dealing with a virus, you're dealing with rewritten code. But for every virus that harms, there are others that heal, or protect, or simply coexist in silence. This brings us to a newer field of study, one that is only just beginning to unfold, the virome. Just as we've come to understand the microbiome, the vast, teeming population of bacteria that live in and on our bodies, scientists now study the virome, the population of viruses that inhabit us quietly. These aren't pathogens, they don't make us sick, they're not trying to spread, they're just there. Some infect bacteria, phages that patrol your gut. Others may live in your cells with no known consequence. Some might even protect you from worse infections by training your immune system or outcompeting more dangerous strains. It's like a microscopic city within you, and viruses are part of the population, not visitors, residents. This challenges our old way of thinking, that viruses are bad and humans are good and health is the absence of invasion. It's not so simple anymore. Maybe it never was. Because viruses don't just shape the present, they shape the rules. Take horizontal gene transfer, a process where genetic material moves between organisms, not by reproduction, but by something stranger, like a leap, a shortcut. Viruses are often the delivery trucks. They pick up genes from one host and accidentally deliver them to another. Sometimes this causes problems. Other times it sparks evolution, new traits, new defenses, new ways of being alive. It's like borrowing a sentence from someone else's story, and discovering it changes your own. And speaking of strange, let's talk about giant viruses. Yes, giant. Which, in the world of viruses, means just barely visible under a light microscope. Discovered in 2003, these viral behemoths, like mimivirus, Pandora virus, and Tupan virus, are larger than some bacteria. They carry hundreds of genes and possess complex structures once thought impossible for viruses. Some even contain parts of the machinery needed to make proteins, something classic viruses lack. This blurs the definition of life even further, because the rule was always viruses don't build proteins, they don't carry ribosomes, they aren't self-sufficient. But giant viruses challenge that rule. They suggest a past we've barely glimpsed, a viral world we've underestimated, and it gets weirder still. Some giant viruses have their own viruses, called virophages. Yes, Viruses that infect other viruses. Imagine that. A virus invades a cell, and another smaller virus invades that virus, disrupting its replication, sabotaging its spread. Parasitism nested inside parasitism, like a Russian doll of microscopic sabotage. It's so strange, so layered, so full of recursive mystery that it almost feels like fiction. And yet, it's real. This is where viruses stop being just germs and start being something else. A network, a system, a history written in whispers. We often imagine life as a ladder. Simple things on the bottom, complex things on top. But the truth is, life is more like a web, and viruses, they're the breeze that moves through it, not separate from life, not beneath it, but part of the scaffolding itself. Somewhere in a lake, in the muddy waters of a cooling tower, a single-celled amoeba swallows something strange. Not food, not another cell, but a giant virus. And inside that virus, yet another stowaway, a virophage, ready to sabotage the saboteur. This isn't a fairy tale, it's a real observation. A virus inside a cell, layers upon layers of interaction, of mimicry, of dependency, each step more delicate than the last. This is the viral world we're only beginning to glimpse, one where viruses don't just infect, but compete, cooperate, and sometimes co-evolve. In the soil beneath your feet, in the air between breaths, in coral reefs and cow stomachs, viruses are quietly shaping the world. In fact, there's growing evidence that viruses are deeply entwined in the carbon cycle, the planetary process that governs how carbon moves through the earth, air, and sea. Here's how. In the oceans, viruses infect vast populations of microscopic plankton, the kind that photosynthesize, that pull carbon dioxide from the air and turn it into organic matter. When those plankton die naturally, their bodies sink slowly, carrying carbon to the ocean floor. But when viruses infect them, the process is faster. The cell bursts, fragments sink, carbon is buried. This viral shattering of life is called the viral shunt, and it may be one of the reasons the Earth climate remains balanced. Imagine that. Climate stability, maintained in part by viral activity in creatures too small to see. It's humbling, and it reminds us that viruses are not limited to sickness. They're woven into the planet's metabolism, into its rhythms, its balances. They are caretakers and saboteurs, destructors and recyclers, tricksters and tutors, and sometimes they're even therapists, or at least allies in therapy. Enter the world of oncolytic viruses, viruses that target and destroy cancer cells. The idea is elegant. Take a virus, modify it so it ignores healthy tissue, and let it loose on tumours. The virus infects the cancer, replicates inside it, and eventually bursts the cell. But that's not all. The process also alerts the immune system, waking it up to the presence of cancer it might otherwise ignore. It's like setting off a fire alarm in a building no one knew was burning. These aren't sci-fi dreams. Clinical trials are underway. Some therapies are already in use. In the near future, a virus might not just make you sick, it might make you better. And that's the paradox. Viruses are both threat and possibility, both destroyer and muse. Because while we spend vast resources trying to stop them, we also borrow from them. Much of modern genetic engineering, from CRISPR to gene therapy, was inspired by how viruses work. They know how to enter cells, how to deliver genetic payloads, how to integrate code into living systems. So we've copied their tricks, reverse engineered them, tamed them in a way. The result? We can now insert genes to correct inherited diseases. We can edit DNA with surgical precision. We can create mRNA vaccines in record time, like those for COVID-19, which use a snippet of viral code to teach your body how to defend itself. None of that would be possible without the centuries-old knowledge of how viruses behave. In that sense, they are teachers, and they've taught us something deeper too, that life is permeable, that our boundaries are porous. You are not just you are a shifting community, a breathing mosaic of borrowed sequences and ancient encounters, and among those, some of the oldest voices to viral. They helped shape your immune system. They whispered through your ancestors, They may one day help cure your grandchildren. It's not a battle, this relationship. It's a long, strange conversation, one that's still unfolding, and as we listen more closely, we're beginning to realize something else. That viruses don't just evolve with us, they evolve because of us. The more we change our world, deforest, urbanize, encroach on wilderness, the more we alter viral landscapes. When we move deeper into forests, build roads through jungles, traffic in wildlife, we expose ourselves to viruses that once had no reason to find us. This is what scientists call zoonosis, the transfer of viruses from animals to humans. It's not new. HIV likely came from chimpanzees, influenza from birds and pigs, SARS from civet cats, SARS-CoV-2, the virus behind COVID-19, likely from bats. These aren't horror stories. They're ecosystems, overlapping, shifting. We don't catch these viruses like surprises. We create the conditions. And viruses, they just do what they've always done. Adapt, replicate, explore the possibilities. So in a sense, every outbreak is a mirror, a reflection of how we live, what we touch, what we change. But if viruses can exploit those openings, we can also close them through conservation, through research, through a better understanding of the invisible worlds we move through. This is where virology becomes not just science, but responsibility, a kind of stewardship. To study viruses is to study the rules of connection, what links one species to another, one moment to another, because viruses don't care about borders, they don't carry passports, they move through breath and blood and chance, and they ask in their quiet, wordless way, what will you do with this knowledge? And that brings us to one last question. What is a virus really? Not just its structure, not just its effects, but its meaning. Is it life? Almost. Is it death? Not exactly. Is it just code? Perhaps, but code that moves, code that dreams, code that's been whispering through the eons, shaping everything we know. We once thought viruses were nature's mistake, a glitch, an accident, a nuisance. But now we're beginning to wonder, what if they're not a flaw? What if they're a feature? Not the villains of biology, but its strange custodians. What if they're here to remind us that life is a process, not a possession, that everything changes, that even what feels still is always in motion, and that sometimes the smallest things hold the biggest truths? A virus doesn't think, but it spreads. It doesn't plan, but it persists. It doesn't choose, but it adapts. And in that pattern of change, survival, response, we see ourselves, not just as victims, not just as hosts, but as part of a larger story, one we're still learning how to read, one written not in chapters but in strands, in molecules, in the quiet looping elegance of evolution. For most of human history, viruses were shadows we couldn't name. They moved through towns, through families, through empires, but no one could see them. We felt their breath in fevers, in coughs, in the strange timing of grief. But they left no footprints, no scent, just patterns. A child falls ill, then a sibling, then the neighbor, then the baker's son, then silence, and no one knows why. Before we had science, we had stories, and in those stories disease had a personality, a punishment perhaps, a bad spirit, an imbalance of humours, a god angry, a wind cursed, a star misaligned. The idea that illness might be caused by something tiny, something invisible, that it might not be magic but math, that idea took time to grow. Long before virus entered the dictionary, other seeds were planted. It began slowly, with the observation of contagion, the idea that disease could spread from person to person, object to object. Even in ancient times, some noticed, the sick clustered. Their suffering wasn't random. Something passed between them, even if no one knew what. But without a name or a lens to see it, contagion remained a ghost. It wasn't until the 17th century that something truly shifted. Enter the microscope. In 1675, a Dutch tradesman named Antony van Leeuwenhoek peered through a handcrafted lens and saw what no human had seen before: a teeming world of animalcules, tiny creatures, alive and swimming in a drop of water, invisible life, bacteria, protozoa, microbial movement in a once-still world. He didn't see viruses, they were still too small, but the world had changed. Now we knew there were hidden realms, and if bacteria existed, what else might be lurking, smaller still? Fast forward to the 19th century, a golden age of microbial discovery. Scientists like Louis Pasteur and Robert Koch were beginning to link specific microbes to specific diseases: tuberculosis, cholera, anthrax. It was revolutionary. Invisible organisms, not miasmas or curses, were causing illness. But there were puzzles. Some diseases didn't fit. Take tobacco plants. In the late 1800s, a strange disease was sweeping across Europe's tobacco crops. Leaves mottled with pale streaks. Wilting, curling, collapse. Researchers filtered sap from infected plants, removing all visible bacteria, yet the disease still spread. Whatever was causing it was smaller than bacteria, unculturable, unseen. In 1892, Russian scientist Dmitry Ivanovsky published his findings. Filtered sap from infected plants still made healthy plants sick, and in 1898, Dutch microbiologist Martinus Beijerinck gave it a name: a contagium vivum fluidum, a contagious living fluid. He believed the agent wasn't made of particles at all, but was some kind of infectious liquid essence. It wasn't. But his experiments had discovered something real: the tobacco mosaic virus, the first virus to be studied, even if it wouldn't be seen for another 4 decades. The term virus had already existed, a Latin word meaning poison, but now it was being reshaped. Not a toxin, but a biological entity, smaller than bacteria, invisible but active. And slowly the list grew. Yellow fever, once thought to be miasma, was shown to be caused by a filterable agent in the early 1900s. Foot-and-mouth disease in livestock, rabies, mysterious and fatal, each was traced to an unseen particle that defied the tools of the time. It wasn't until the 1930s, with the invention of the electron microscope, that scientists finally saw a virus. And what they saw was strange: tiny geometric shapes, icosahedrons, helixes, spiky spheres like something from a minimalist sculpture garden. Beautiful, in a sterile sort of way, simple, but terrifyingly efficient. The tobacco mosaic virus became the first virus ever photographed, a rod-shaped crystal of infectious code. And suddenly, what had been theory became image, proof, presence. Through the mid-20th century, the field exploded. In 1952, scientists Hershey and Chase used viruses to prove that DNA, not protein, was the carrier of genetic information. Their experiment using a bacteriophage and radioactive markers confirmed that it was DNA that entered cells and carried the instructions of life. It was a virus that revealed the secret of heredity. Soon, viruses became tools as much as threats. In research labs, bacteriophages, viruses that infect bacteria, became models for studying genetics. They were simple, easy to manipulate, and fast. They helped build molecular biology from the ground up. But even as they served science, viruses were changing the world in other ways. In the 20th century, waves of viral diseases defined decades. Polio, a virus that left children paralyzed, swept through the world until a vaccine, developed by Jonas Salk in 1955, changed the tide. Parents once feared swimming pools and summer months. Now, with a few drops of sugar and science, that fear began to recede. Influenza, which had killed tens of millions in 1918, returned again and again. Seasonal, unpredictable, always shifting. HIV emerged in the late 20th century, a virus unlike any before it. Slow, silent, devastating. At first, no one knew what to call it. It moved through communities already marginalized, and the stigma was as deadly as the virus itself. But eventually the science caught up. By the 1990s, tests were available. Then treatments. Then combinations of drugs that could turn a death sentence into a chronic condition. Still no cure. But knowledge was catching up, and hope followed. In recent years, gene therapy, once a dream, has become reality, using modified viruses to deliver corrected genes to cells, turning invaders into couriers, code into medicine, and then came COVID-19, a virus that reshaped the early 21st century. It didn't sneak in. It arrived with fanfare. Unseen but unstoppable, it locked down cities, emptied schools, paused weddings, stilled airplanes. And once again, humanity turned to science. Vaccines were developed in months, a timeline once thought impossible. mRNA technology, decades in the making, delivered a new kind of immunity, a blueprint not of the virus itself, but of the spike protein it used to enter cells. Your body learned the invader's face before it arrived. And in that moment, a new chapter of virology was born. One where viruses didn't just represent the past, but helped define the future. A future of rapid vaccine development, of personalized medicine, of deeper understanding. But it hasn't been linear. Science never is. There were missteps, failures, politics and fear and misinformation. And still, the work continued, quietly, patiently. Because that's how we learn. In loops, in slow spirals, in repeated questions and better tools. Today, we know of hundreds of thousands of viruses. We've classified some, named others, and many, the vast majority, remain undiscovered. Not because they're rare, but because they're small and quiet and everywhere. The more we look, the more we find. In hot springs, in ice cores, in deserts and intestines and the darkest parts of the sea. And with each discovery, the question deepens. What are viruses? Really? Mistakes? Ancestors? Messengers? The truth is, our understanding is still evolving, not just scientifically, but philosophically. A virus isn't just a threat, it's a window, a question, a reminder that we don't know everything, and that's okay, because every generation adds to the picture, with microscopes, with models, with metaphors, and the story continues, from tobacco leaves to telescoping genomes, from filterable agents to spike proteins, from fear to understanding, and sometimes back again. Science moves like a virus, through repetition, through mutation, through the quiet rewriting of the known. And maybe that's the most viral thing of all. Not the particles, but the knowledge, the sharing, the shift, the slow unraveling of mystery, one discovery at a time. Let's imagine, just for a moment, that you could see everything. Not just the furniture in your room, the glow of a screen or the curve of a cup, but the invisible world around you. The air thick with movement, particles drifting, molecules bouncing, tiny passengers brushing against your skin like moths made of data. Some of them are dust, some pollen, some microbes, and some perhaps are viruses, floating, waiting, listening in their own wordless way. And now imagine this. What if those viruses aren't separate from you? What if they're not invaders, but threads in the same fabric? Not guests in the house of life, but part of the blueprint in the walls. It's a strange thought. But many truths begin that way. Viruses are often defined by what they're not. They're not truly alive. They're not self-sustaining. They're not conscious, or mobile, or even consistent. They are exceptions to the rules, living shadows, barely their beings that shape everything. But what if we asked a different question? Not, are viruses alive, but what does it mean to be alive at all? The classic answer is a checklist. Metabolism, growth, reproduction, response to stimuli. A plant qualifies. So does a bacterium, a human of course, but a virus. It's a paradox. It doesn't meet the criteria until it does. On its own, inert, inside a cell, unstoppable, no heartbeat, no hunger, but it spreads, it adapts, it remembers in the way only code can remember. Is life a state, a property, a spark, or is it a relationship? Because if life is about connection, about interaction, dependency, the flow of influence, then viruses qualify. They are, in a sense, the most relational entities we know. They cannot do anything alone. They only exist in context, in contact, and in that way they mirror us. Because humans too are made of relationships. We are not sealed containers of self. We are collaborations, symphonies, woven networks of cells and microbes, memories and meanings. Your body is home to trillions of bacteria, millions of viruses, and even remnants of old viral code tucked into your DNA like marginalia in an ancient manuscript. Are you still you without them? What if identity isn't fixed, but layered? What if being human means being in conversation with the not quite human things inside you? Maybe we're not the authors of our biology, but co-writers. Viruses don't have intention, but they have impact. They shape evolution, change species, shuffle genetic material like cards in a deck we didn't know we were playing. That leads to another question. If a virus can change a species over time, can it be said to have agency? Not in the way we think of choice, not desire or preference, but influence. Unthinking, perhaps, but undeniable. You're here now, in this body, with this brain, in part because of ancient viral events that happened long before history had a name. That's not metaphor, that's genetics. Some researchers have even proposed that consciousness itself, the capacity to reflect, to imagine, to suffer, may be built in part on proteins originally shaped by viral genes, the scaffolding of thought, gifted by something that cannot think. There's poetry in that, and a little vertigo, because it challenges how we see ourselves, not as singular minds atop a pyramid of life, but as accumulated consequence, living palimpsests rewritten again and again by encounters we never chose. And what of time? Viruses operate on a scale that mocks our calendars. A single replication can take minutes. A mutation can shift the course of history in a weekend. And yet some viruses lie dormant for decades, like biological secrets waiting for the right chapter to reveal themselves. They are fast and slow, ancient and new. They live in the moment but also stretch across deep time, and so do we. There's a concept in physics, the idea that time may not be linear, that past, present and future exist simultaneously, like rooms in a house we can only visit one at a time. If that's true, then perhaps the virus isn't a threat from the outside, but a message from another room, something that reminds us again and again that life isn't static, that even the smallest things can turn the story. And what about death? We associate viruses with endings, a failed defense, a breakdown, an absence, but perhaps that's too narrow. Viruses also begin things, new immune pathways, new genetic variations, new relationships between species. They kill, yes, but they also clear space for change, for evolution, for the emergence of new life. Some scientists call viruses agents of innovation because every time they infect, they experiment, they shuffle, they take risks. Most of those risks lead nowhere, but some reshape the world. It's almost artistic, a kind of creative destruction, without vision, without vanity, pure process. And what of the future? Will viruses always be our antagonists? Or might they become something else? Already we use viral vectors to deliver gene therapy, to correct inherited disorders, to help the immune system recognize tumors. We're studying viruses that live in extreme environments, boiling vents, frozen tundras, to unlock new possibilities in medicine and bioengineering. We're even engineering synthetic viruses, fragments of code we design ourselves, to do our bidding. It's a strange irony that the thing we fear the most may also become our collaborator, our tool, our bridge to new forms of healing. But this raises another question. Where is the line between natural and unnatural? If we take a virus and redesign it, is it still a virus? Or has it become something else? And if a virus alters our biology, do we remain the same? Or are we changed, not just physically, but ontologically? A different kind of being carrying a different kind of code? There's no clear answer. But there is beauty in the asking. Perhaps that's the true gift of viruses, not certainty but curiosity. They remind us that knowledge is provisional, that science is not a fortress but a field, open, shifting, always in bloom. They push us to wonder, to rethink what life is, to accept that control is an illusion, and that survival often means surrendering to complexity. Even our fear of them is a form of awe, because fear at its core is the recognition of power, and viruses are powerful. Not because they are evil, but because they are elemental. Part of the way life works, part of the way change enters the story. You might say they are the punctuation in the sentence of biology, the commas of pause, the colons of surprise, the ellipses that trail off into a new chapter we didn't know was coming. So where does that leave us? Still here, still breathing, still wondering, still walking through a world that is older, stranger, and more interconnected than we ever imagined. And somewhere, out there, or perhaps right inside you, a virus is drifting, not aware of you, not aware of itself, but still part of your story, a fragment, a footnote, a flicker of possibility in the long unfolding mystery of being alive. You wake up with a scratch in your throat, maybe a heaviness behind your eyes, nothing dramatic, not yet, just that quiet whisper from your body. Something's off. You reach for tea, cancel a meeting, tell yourself it's probably nothing, and then, by evening, it's something. Your nose starts to run, your voice drops half an octave, and your world begins to shrink. From big plans and bright ideas to tissues, blankets, thermometers, and soup. You're not alone in this. Most people on Earth will get a viral infection dozens, maybe hundreds of times in their life. Colds, flus, fevers that flicker and fade. Some are mild, some linger, some become stories. I was so sick I couldn't get out of bed for 3 days. My voice sounded like gravel. It hit me like a train. And yet we rarely pause to consider what's actually happening. That in those quiet, miserable days of sneezing and soup, you're participating in an ancient planetary ritual, a microscopic dialogue, a temporary rewrite. Your body meeting an old stranger with new clothes. Because most of these viruses aren't new, they're recycled. Passed hand to hand, breath to breath, city to city, a library of infections that knows its way around. You catch something in winter, then again 2 years later. It's familiar, but slightly different. The virus has changed, and so have you. This dance of infection, recovery, adaptation is part of daily life, and yet we rarely think of it that way. We think of illness as interruption, as failure, as something to fix. But on another level, it's a kind of training. Every time you get sick, your body learns, it remembers, it stores little molecular fingerprints so that next time you'll respond faster. And while you rest, wrapped in blankets and half watching bad TV, your immune system is running drills, reading blueprints, marking targets. You're not passive, you're hosting a war room, and when you recover, which most of the time you will, you come out stronger, changed, updated. That change, that subtle reshaping of your inner defenses is happening all the time. Every handshake, every train ride, every school hallway, even the casual exchange of a pen or the shared grip on a shopping cart. It's a reminder that our lives are porous, that being human means constant contact, and that even when you feel alone, your biology is in conversation. Of course, we don't usually frame it this way. We just say, I caught something, and then we sip broth, cancel plans, and wait. And even when we're not sick, viruses shape our choices. They live in the background of behavior. Think of the cultural rituals that orbit around illness, the kindness of someone bringing you ginger tea, the quiet apology when someone coughs in a crowded space, the habitual stockpiling of tissues in winter, or the way whole calendars change because of flu season, school stagger breaks, pharmacies hang signs, get your shot early this year. We mark time not just with holidays and harvests, but with outbreaks. They become seasonal characters in the play of the year. Flu in winter, stomach bugs in spring, the dreaded cold right before a big event. Sometimes we even share them as jokes. Don't come near me, I've got the plague. We don't mean actual plague, but the metaphor lingers because we know instinctively that viruses move through us all, that they level us, regardless of titles, plans, or good intentions, and yet we also use them to connect. Think of the messages. Hey, just letting you know I was sick yesterday in case you feel something. It's a small act of care, an invisible thread between two immune systems. And when illness becomes widespread, a community outbreak, a flu that sweeps through a workplace, there's a strange solidarity in it. You're sick, I'm sick. We compare symptoms, swap remedies, grown together through it all. Misery, yes, but shared. And then, of course, there are the big events, the ones that change behavior, that shape entire generations. Children who live through pandemics grow up with new instincts, the awareness of air, the hesitation before hugging, the sight of a mask feeling oddly normal. It enters the language, the architecture, the everyday rituals of prevention, hand sanitizer by every door, the new etiquette of illness, stay home, stay safe, don't power through. A cough used to be a minor nuisance. Now it carries weight. It's an announcement, a signal. And though we'll relax again, and we always do, some changes stay. Because once you've seen how quickly the world can shift, you don't unsee it. And while viruses disrupt us, they also remind us what matters: health, connection, compassion. You bring someone soup, you text them to check in, you say, I hope you're feeling better, and you mean it. Because we all know what it's like to be curled up, aching, waiting for the fog to lift. And through that shared experience, viruses sneak into our stories. Not just the science books, but the culture. They become metaphors. We say a meme went viral. A bad idea infected the conversation. We speak of things spreading like a virus when they move fast and change people without warning. Even love can feel like a virus. Sudden, involuntary, consuming. It arrives. It rewires. You're not quite the same afterward. And then there are the myths. The zombie virus, the alien plague, the computer virus that shuts down the world. They show up in novels, movies, dreams, not because we want to suffer, but because we are fascinated by the idea of transformation. Viruses symbolize change, unseen, unstoppable, intimate change. They raise the stakes. They challenge the heroes. They remind us how delicate the threads of society really are. And yet, they also show how strong those threads can become. In every story of outbreak, there's also a story of resilience, of people finding ways to care for each other, of scientists racing to understand, of communities adapting, rebuilding, healing. Even the rituals of recovery are cultural. The first breath of fresh air after a fever breaks, the celebratory return to solid food. The way we describe recovery as a return, I'm finally myself again, but you're not quite the same, not biologically, not emotionally. Your immune system remembers, your calendar shifted, you missed something, or postponed something, or reimagined something, and that too becomes part of the rhythm of life. We plan, we get sick, we adapt. Sometimes the virus wins, sometimes we do. Often it's a draw. But the dance continues, and in between the coughs and the quiet, there's something strangely comforting in knowing that this too has happened before, and will happen again. Because we're not separate from nature. We are porous, fluid, participatory, and viruses, as strange and unsettling as they are, remind us of that. They don't knock at the door. They come in with the wind, the breath, the moment, and when they pass, they leave a mark. Not just on cells, but on memory. So the next time you're bundled up, head heavy, cup of tea steaming in your hands, remember, you're in the company of billions. Not just the viruses, though they're certainly there, but all the people who've been where you are, who've watched the same quiet snow fall through a window, while their bodies did the silent work of healing, and all those who brought soup, who whispered rest now. Because to be alive is to share in these cycles, to ache, to mend, to carry the memory of viruses not just in your cells, but in your stories. What if viruses didn't just make you sick? What if they made you different? Not in the obvious ways, not coughing or aching, but in subtle, permanent shifts. What if a virus could change how you dream, or how you remember childhood? What if it could tilt your perception of time, soften your sense of self, open up a small doorway in the brain that had been locked since birth? There's no evidence, of course. But let's wander down the what if anyway, because sometimes imagination is just science waiting for a method. What if a virus doesn't just copy itself inside your cells, but leaves behind messages, like annotations in your DNA, a margin note that says, "Try this instead"? We already know that viruses can carry genes between species, that they can shuffle blueprints, that some of our own proteins, the ones that build brains, blood, even the placenta, are ancient viral gifts. So what if consciousness itself is one of those gifts? Not all at once, not in a flash of lightning, but slowly, mutation by mutation, accident by accident, until one day a creature stares into a still pond and recognizes its own reflection. A moment of self, of story, of wonder. And what if the spark behind that moment came from something we can't even classify as alive? Let's go further. What if viruses are part of a planetary operating system, a kind of distributed intelligence, not conscious but computational, not thinking but testing? What if every time a virus mutates, it's not just chance, but part of a much larger algorithm, a planetary software update, something nudging life along, invisible hands rearranging the pieces so that evolution doesn't stagnate? If you saw this in a sci-fi movie, you'd call it far-fetched. But the metaphor is already halfway true. Viruses move genes. They cause sudden leaps. They break systems in ways that create new ones. They don't plan, but they shape. And isn't that what intelligence is in the broadest sense? Not prediction, but pattern. Now let's shift the scene. Imagine Earth from the perspective of a virus. Not a single virus, but all of them, as a collective. Billions upon billions drifting through every biome, hitching rides on birds, swirling in ocean currents, bouncing between species with the ease of pollen in spring. From that vantage point, we aren't hosts, we're habitat, a system to explore, a warm, breathing network of possibilities. Every immune system's a puzzle, every cell a potential home. And what if, just what if, some viruses remember, not like we do, not with language or images, but in structure, in sequence, in the way an old path grows smoother with each passing footstep. A virus doesn't have a brain, but it has history, and sometimes history is enough. Now let's go stranger. What if viruses didn't originate on Earth? It's called the panspermia hypothesis, the idea that life or its building blocks might have arrived here on comets, asteroids, interstellar dust. Some versions of the theory suggest viruses were among the first to arrive, tiny crystal-like forms of RNA and protein drifting through the void, resistant to radiation, waiting for the right conditions to wake up. Could a virus survive in space? We've already found that some can. Not all, but enough to make the question worth asking. Imagine, somewhere, billions of years ago, a meteor crashes into a lifeless Earth, and with it, a strand of something that isn't quite alive, but knows how to copy itself. And from there, the story begins. Not human history, but the history of instruction, the unfolding of structure, a cascade of complexity, that first moment when matter began to whisper, "Do this, then do it again." And suddenly, the line between biology and destiny begins to blur. Let's flip the lens again. What if viruses aren't just pieces of information, but pieces of communication? What if they're how life talks to itself, how ecosystems regulate, how species negotiate? You might think this is too abstract, too poetic. But consider, in soil, viruses control bacterial populations. In oceans, they drive the carbon cycle. In your gut, they shape the microbiome. What if that's not incidental? What if it's language, spoken in protein, written in sequence, translated through time? We tend to think of viruses as silent, but maybe we just don't know how to listen. And what about the dream world? There's no evidence, none, that viruses influence dreams. But still, the idea lingers. You get sick. You sleep for hours, days, curled in a fevered fog. And sometimes the dreams are different, more vivid, more surreal, unanchored from logic, as if something has loosened the grip on reality. It could be just biology, cytokines and temperature and altered REM cycles. But what if illness opens a gate, not to another world, but to another part of your own mind? A room you usually keep locked, one filled with strange imagery, half-formed thoughts, unresolved memories. And what if the virus, while copying itself in your cells, also copies something else? Not memories, but moods, fears, ideas, not as theft, but as residue. Like ink on a page that presses too hard, leaving a faint trace on the sheet beneath. What if your dreams when you're sick are a dialogue with your own biology? A surreal attempt at integration. You wake up confused, maybe wiser, maybe not. But something has shifted, even if you don't know what. Let's spin one more thread. What if we built technology that thinks like a virus, not malware, not computer infections, but algorithms designed to be small, simple, self-replicating, evolutionary, artificial intelligence that doesn't grow linearly, but virally, that doesn't seek permission, but explores? What kind of systems would that produce? Would it be dangerous, liberating, beautiful? Some computer scientists already think in these terms: self-spreading updates, code that adapts in the wild, decentralized intelligence. Maybe the future of machine learning will take lessons from nature's oldest replicators. Because viruses aren't complex, they're elegant, efficient, just enough. And that might be the best kind of design. Or maybe the most unsettling possibility of all. What if there's no meaning? What if viruses aren't messengers, or ancestors, or instruments of change? What if they're just there? Accident of chemistry, byproducts of replication, noise in the system. And yet, even if that's true, even if they have no purpose, no direction, no grand design, they've still changed everything. They've shaped species, toppled empires, united strangers in moments of care, taught scientists how to think smaller, simpler, deeper. Sometimes impact doesn't require intention. Sometimes meaning is something we bring to the pattern. A virus isn't trying to teach us anything, but we're still learning. And maybe that's the most human thing of all. We take what scares us and turn it into story. We take what we don't understand and stretch it into possibility. We whisper, "What if?" and listen for the echo, even if that echoes a silence drifting on the air, waiting for the next open door. Maybe viruses aren't what we thought, not monsters, not mistakes, not just the villains of the microbial world. Maybe there's something else entirely, something smaller, stranger, quieter, not life, but life adjacent. Not intelligent, but intelligent in effect, not separate, but part of everything. When we began this journey, we asked a simple question: why do viruses rule the planet? And maybe now the answer is less about power and more about presence. They don't rule through dominance. They rule through participation, everywhere, always, unseen but undeniable. Let's pause and remember what we've uncovered. We began with their mystery, these tiny, invisible packets of code that lie dormant for decades or explode into motion the moment they find a host. They don't eat, they don't move, they don't breathe, but they act, they replicate, they persist. And in that strange persistence, they shape life. We saw how viruses are not quite alive, but not dead either. They hover in some liminal space between form and function, waiting for another organism to complete the story. They are relationship incarnate, meaningless alone, mighty in context. We explored the human connection, how illness and recovery are deeply woven into the rhythms of our lives, the colds that shape our calendars, the flus that teach us rest, the pandemics that reset entire civilizations. Viruses don't just affect our biology, they become part of our stories, our memories, our culture. We live among them, We learned through them, then we zoomed out into the broader science. We followed the virus into the oceans where it drives the carbon cycle, balancing the breath of the planet. We followed it into our own genes and found it already there. Ancient retroviruses, now part of our DNA, silently influencing the very way we grow, reproduce, and defend ourselves. We saw viruses as teachers, guiding the development of genetics, revealing how DNA works, helping scientists build tools to fight disease and reprogram the body for healing. We saw viruses as healers, used in therapies to attack cancer, to deliver corrected genes, to offer immunity against greater threats. They can wound, yes, but they can also restore. We stepped further into metaphor, into dream. What if viruses didn't come from here at all? What if they were gifts from the stars, tiny seeds drifting through the cosmos, waiting for the right chemistry to wake up? What if they aren't just mistakes of evolution, but its accelerators? What if they don't represent danger, but the necessary discomfort of change? You don't have to believe these things literally, but you can let them move you, like a soft idea brushing the edges of your certainty. Because the truth is, viruses complicate our categories. They force us to reconsider definitions. What is life? What is health? What is identity? When part of who you are was written by something that once wanted to copy itself in you? There is no clear answer, only possibilities. And isn't that beautiful? Science often feels like the pursuit of certainty, but in its best moments it brings us back to wonder. Viruses are full of that wonder. They're older than mammals, older than trees, older than memory itself. They have witnessed the rise of every species, and they will likely outlast us, not out of malice, not out of desire, just inevitability, like wind, like time. But here's the strange comfort. They're not separate from us. They're in us, with us, of us. You have viruses in you right now that aren't making you sick, that may in fact be protecting you, tuning your immune system, balancing your microbiome. You are not an individual. You are a community. A walking, breathing ecosystem co-authored by bacteria, co-edited by viruses, maintained by the memory of past encounters with things you never even noticed. And when you get sick, when a virus makes its presence known, it is not a betrayal. It's part of the dialogue, the constant recalibration of a living system in motion. Yes, sometimes that dialogue is painful. Sometimes it ends lives. But even then, the conversation continues. We evolve, we remember, we build immunity, we pass down antibodies, we write vaccines, we leave warnings for the next generation, and the viruses without memory, without intent, move on, searching for the next cell, the next story, the next chance. It's not war, it's weather, it's not evil, it's existence. And in that realization, there's a kind of peace. You don't have to hate the virus, you don't even have to fear it. You can simply witness it, learn from it, respect its role in the world, without giving it more drama than it deserves. Because if viruses rule the planet, they do so the way wind rules the mountains. Not with violence, but with persistence, with presence. They don't care, they don't need to, and somehow they've still shaped every breath we take. So maybe the better question isn't, why do viruses rule the planet? But what can we learn from something so small, so strange, and so deeply embedded in the fabric of life? Maybe we can learn humility, patience, curiosity. Maybe we can learn to see ourselves not as fragile towers under siege, but as dynamic systems, capable of change, resilience, renewal. Maybe we can remember that science isn't about control, it's about understanding, and that sometimes understanding starts with stillness, with slowing down, with asking questions that have no answers, at least not yet. Because viruses teach us this too, that waiting is part of the process, that what you don't understand today you might one day illuminate, and what scares you now might someday be your teacher, your ally, your cure. So here we are, at the end of this exploration, and perhaps the beginning of another. We began with cells, and now we're looking at stars. We began with a cough, and now we're speaking of consciousness. That's the beauty of soft science, of quiet thought, of sleep-minded wonder. It spirals, it stretches, it soothes. And it reminds us that learning isn't always loud. Sometimes it's lullaby. So close your eyes, let the facts settle like snow, let the questions rest beside you, unanswered but alive. You don't need a conclusion, just a breath, a softness, a sense of something vast and invisible moving through the world, not to hurt you, not to save you, but to remind you that change is always nearby, just waiting for a cell, a thought, a moment, and when it comes, may you greet it with open wonder. So, where are you now? Still here, I hope. Maybe lying down, maybe just breathing quietly, maybe halfway between waking and sleep, drifting in that soft in-between where time feels like syrup and thoughts float rather than walk. If you've stayed with me this far, through cells and cycles, through retroviruses and reflections, through deep oceans and even deeper questions, thank you, truly. Because this wasn't just about viruses. It was about wonder, about listening to something small until it reveals something vast. That's the rhythm of the world, isn't it? The smallest things carry the biggest stories. The quietest forces shape the loudest chapters. The virus, the breath, the moment, and you. With your body made of stars and memories and molecules and mystery, you are part of that rhythm. You're not outside the system. You are the system. Living proof that biology and beauty are not separate things. So wherever you are now, bedroom, train seat, corner couch, beneath blankets, beneath sky, know that this space we made together, this little pocket of stillness, is always here. You can return to it, any time, any night. And if this gave you peace, if it helped you slow down or see something old in a new quiet way, I hope you'll join me again. You know the way. Until then, sleep well, fellow traveller, wherever and whenever you are. Good night.